Hey everybody, especially you, Jim. Welcome back to RC with Adam. My name is Adam. Today we're looking at the Crux 1, a relatively new mini 3D printer from TronXY, or possibly TronXY. I don't really know how to pronounce their name, and it would be great if all 3D printer manufacturers could have names that we could pronounce and know how to pronounce that. That would be great. Full disclosure, TronXY did send this to me free of charge to test and review for this video, and I will be keeping it afterwards. In this video, I'll cover the specs and features of the Crux 1, compare it to other 3D printer options, give you my opinion of it, and answer the burning question, is this a good beginner 3D printer? But first, here's the bottom line up front, because you know I don't like wasting your time. This may be the least expensive option on the market right now if you want both silent stepper drivers and a direct drive extruder. I think the balance of build quality and features with the current price of $180 US makes this a solid printer option as long as you want to print items that are smaller than 180 millimeters, or you don't want to print anything larger than 180 millimeters. The print bed size is really the biggest difference between this and other larger, more expensive printers. Is this a good printer for beginners? Are you a beginner? Are you just getting into 3D printing and you're like, is this a good printer for me? I would have no problem recommending this to a friend wanting to get into 3D printing for under $200. So yes, it is. But the TronXY XY-2 Pro model may be an even better bang for your buck if you want to maximize print volume at the expense of the direct drive direct drive extruder. More on that later. Okay, that's the bottom line. Now let's get into let's get into more details on the Crux 1. Quick disclaimer, I have not had this printer for a very long time and have not had much print hour time on it to really put it through its paces and tinker with it as much as I would like. I also just upgraded to the latest version of Cura Slicer, and I've been really behind on that, so it's kind of like a big jump. So I'm still learning what print settings and filaments work best for this printer. With that said, let's get into the specs and features of the Crux 1. I'll cover the highlights here and put the specs up on the screen and a link to the product page in the video description so you can check out all of the details. First, what you'll notice right away is that the Crux 1 is built with a cantilever style frame, which means it uses one vertical extrusion for the Z-axis, as opposed to the super common i3 style, which uses two vertical extrusions, one on either side of the print bed to make up the Z-axis and support the gantry that holds the print head. Secondly, like we already discussed, is the size. It's quite small and it has a 180 millimeter square print bed and can print 180 millimeters vertically. The print bed is heated and can go up to 110 degrees Celsius, but that's double what you'll need most of the time, usually printing at about 60 to 50 degrees for the bed temperature. The print surface that mine came with is a PEI coated metal sheet, which sticks to the print bed using a magnetic sheet that you will adhere to the print bed itself, kind of like a magnetic sticker. Personally, I don't care for the rough surface texture, and I prefer to print on a mirror or coated glass surface. But the removable metal sheet makes it very easy to remove the finished print, so that is nice. For bed leveling, it uses the standard 4 corner screws and springs with another thumb screw to easily adjust the Z-axis minimum height, which I like because it's much easier than fiddling with a Z-axis limit switch that's kind of like bolted onto the aluminum extrusion of the frame, which is pretty common with other, especially older Creality style designs. Now, I really wish it came with an auto bed leveling system on here, as I think it would make an even smoother and less fiddly and frustrating experience for beginners. I don't know if it is possible to add an ABL system onto this later, and it's not mentioned on the website at all. So I don't know if that's possible, but that would be super great because that's one of the most annoying parts of setting up a 3D printer. I did have a difficult time leveling this print bed, and I did have to adjust the Z limit screw to get the nozzle closer to the bed, but it probably wasn't much harder than any other printer, and it was easier to adjust the Z limit screw by just, tightening down that little screw instead of messing with something that was attached to the frame. Another note about the bed, it uses a toothed drive belt with multiple pulleys to move the bed forward and backward, which makes up the Y-axis. This is not unusual, but the way the drive pulley is offset to the side of the print bed makes it much easier to get pieces of filament or other debris caught up in the belt. So keep that in mind. During the first prints, it appeared that the initial extrusion priming line was set too far to the left of the build plate, because I'm pretty sure I lined up the build plate properly. So some of the filament missed the build plate and kind of fell down into the drive belt. And so that was almost a problem, but I was able to get it out before it really worked itself in there. I'll have to look into this further, but the easy fix was to just slide the metal print sheet as far left as I could without hitting the Z-axis extrusion. By the way, when we say extrusion in terms of the frame, we're talking about the aluminum extrusions, because that's how those parts are produced. Those aluminum pieces that make up the frame, those are called extrusions, which I realize can be confusing because we also talk about extruding the filament, but just keep that in mind in terms of the context. Now, taking a look above the print bed at the print head, it claims to have a maximum nozzle temperature of 275 degrees Celsius, but for most prints with PLA or TPU, you'll be at around 220 degrees Celsius. So if you do something like, I guess you could print with ABS or something where you need to have higher temperatures, and you'd be able to manage that. It has a large blower style fan for cooling the printed filament and a common rotary style fan for cooling the nozzle heat break. I think the larger than average cooling fan helps to keep the high pitch noise down when it's running, and that's a good thing. However, I think the fan nozzle itself could be improved, probably with a multi-angle design to cool the print from multiple directions, or maybe even completely wrap around the nozzle in a way. And I think this could be designed, printed, and added later if someone hasn't done it already. Next, we have one of the main attractions of this printer, which is the direct drive extruder, which is located directly above the nozzle. Now, in case you don't know, a direct drive extruder means that the motor-driven gears that are used to grip and push the filament through the nozzle are placed very close to the nozzle itself, as opposed to the other Bowden-style extruders, which places the extruder on the frame of the printer, and the filament is pushed through a tube which guides it into the nozzle. So the difference is kind of how close the extruder gears are to the actual printing nozzle itself. The advantage of a direct drive is that it tends to work better with very flexible materials and leaves less stringing during printing. And I also find it's easier to load and remove filament with less waste. The downside of a direct drive style is that it adds more weight to the print head, which can introduce more problems when you're printing at higher speeds because of that extra weight that's having to be moved around. Although I have not actually tested this myself because I tend to print much more slowly anyway. What I find interesting is that the Crux 1 uses this type of extruder even though it's a cantilever style frame. So I haven't seen this combo before, and I wonder if it's because of the extra weight on the single Z-axis arm, and maybe that's what scares manufacturers off about it. I'm not sure, but so far I can't tell if it's going to be a problem or not. I also haven't had any problems with it so far. Now, one of the best things about this printer, and this would be a deal breaker for me, is that it uses silent, or sometimes called muted, drivers for the stepper motors. Stepper motors are used to move the bed, the print head, and the extruder gears, and can be annoyingly loud if they are controlled with older non-silent driver electronics. With the silent drivers, the motors just make a low hum rather than a very kind of like electronic sound. What? That is so cool. That is, oh. There is still a high-pitched noise from the tiny cooling fans, both on the print head and inside the base of the printer, where the power supply is located, but it is much quieter than it would be otherwise. Still, it is loud enough that I would not want this on a desk right beside me if I'm trying to concentrate on other work. Both the X and Y axis use metal guide pulleys to slide across the polished guide rails. This is opposed to the very common hard rubber V-shaped wheels, which would roll in the channels of aluminum frame extrusions, or the less common linear guide rails. This metal guide pulley system seems like a great idea to me and works well so far. Oddly though, the Z-axis still uses the rubber V wheels. I'm not sure why this is, but if you think you know, leave a comment down below. There is a filament spool holder that is screwed to the rear left of the printer, which allows the filament to be fed upward onto the filament guide tube, which looks like a Bowden tube, but it's actually not, which leads to the extruder at the printhead. Mine came with the tube zip tied to the wiring bundle, but I found that it caused added stress to the filament in the tube, so I cut the zip tie and I think it works much better this way. Now I'm curious if the filament holder could just be directly mounted above the Z-axis and fed straight down into the extruder, but I'm guessing a 1 kilogram spool of filament might cause swaying issues since there is only one Z-axis extrusion as opposed to having two, like to have a more rigid frame. Still, I might give this a try because I think it would look cool and it would greatly reduce the space that this machine takes up, because it seems like kind of a shame that you have this tiny little printer, but then you got to put the filament like next to it off to the side, and so it's just kind of awkward. There is also a filament runout sensor at the beginning of the guide tube, which is supposed to alert you and pause printing in case the filament gets used up before the print is done. I've actually never had a use for this feature on any printers, and I doubt that I ever will unless I'm printing some supermassive model and trying to use the last remnants of a spool. But especially given the print volume of the Crux One, I highly doubt that will ever come up. But if this feature has saved you in the past, please let us know in the comments. Taking a look at the built-in screen, I'm not crazy about it. It's large enough and easy enough to navigate the menus, I guess, but the touchscreen has a squishy and unresponsive feel. Also, when trying to preheat the machine to heat the nozzle up to load or unload filament, I wish I could just save a custom preheat option instead of having to press the up temperature arrow a whole bunch of times. And also, why does it only change the temperature in 4-degree increments? The most common nozzle temperature is right around 200 degrees, I mean, especially for just preheating. So why not move in at least 10-degree increments, or just make 200 degrees the default for preheat, or even like 180 degrees the default for preheat? I don't know. Somebody please tell me why. Please fix that, TronXY, because that just doesn't make any sense. The X-axis belt has a thumb screw to easily adjust the tension of the belt, which is nice. I'm actually still not sure how to adjust the tension of the Y-axis belt, and there's no mention of it in the booklet that comes with the printer, but both arrived well tensioned. And finally, I do really like that the Crux One has a common USB-A port in addition to the standard micro SD card port. And I like that it is in the front and very easy to access. As far as the assembly, it was really very quick and simple, with the initial leveling of the print bed taking the most time during setup. And I do have a video explaining more about the unboxing and setup as well, so you can go check that out. And for reference, here's a size comparison with the Creality Ender 3, which has a 230 by 230 millimeter print bed. And also here it is compared to the Focus Odin 5, which has, I believe, a 235 millimeter square print bed. Okay, now that you know more details about the Crux One, let's briefly take a look at similar options from other manufacturers so you can get an idea where this stands against the competition. We're taking a look at the Prusa Mini, the Creality Ender 2 Pro, Creality Ender 3 V2, TronXY XY-2 Pro, TronXY XY-3. Now, in terms of the mini cantilever style printers, two that really come to mind that seem the most prominent are going to be the Prusa Mini and the Creality Ender 2 Pro. And really those are kind of like the high end and the low end. With the Prusa Mini coming in at $479 and the Ender 2 Pro coming in at $145, which is a little bit below, about $40 less than the Crux One. Now with the Prusa Mini, here's the thing, like if you're looking at this 3D printer, then the Prusa Mini is obviously out of that budget at all. Like I'm not totally sure what the point is of that. Prusa, the brand Prusa, I've never used their printers, but I understand they're kind of like the godfather of the 3D printers, and they're good printers, but to some extent it's kind of like you buy a Prusa because you want a Prusa, is kind of the feeling that I get. But in any case, in terms of the specs, it has some other features like some Wi-Fi capabilities and stuff, but it has a 180 by 180 cubic, or square bed with 180 vertical print size. It does have auto bed leveling. It does have silent drivers, and it has a Bowden extruder. So it still doesn't have that direct drive, which I like. Now, the Creality Ender 2 Pro, that one's again coming in at $145 US. It has a slightly smaller build volume at 165 by 165 millimeters area on the print bed, and it prints vertically 180 millimeters. It does not have auto bed leveling, so just manual, just like the Crux one. It does have silent drivers, but it still does not have that direct drive extrusion, so it uses a Bowden style extruder. So yeah, that's why I say between at least these other two mini options, the Crux one is really kind of right in between there. It's only a little bit more than the Ender 2 Pro, and it's less than half as much as the Prusa Mini, and I like the feature set that it has. Now, here's the thing though, looking at some other sort of quote unquote full size, or maybe small full size i3 style printers, one that really sticks out is actually the TronXY XY-2 Pro. And that one's $183 right now. And it has a print bed 255 by 255 millimeters and prints 260 millimeters vertically. So it looks like it's right about the size of like an Ender 3 Pro or an Ender 3. It does have silent drivers, and it uses a Bowden style extruder, so no direct drive, but it does actually have auto bed leveling. So I'm really thinking that could be a good option. And I haven't looked at all of the ones from every single company, but since it's the same price as this mini one, and you're still getting silent drivers, which again to me is a deal breaker. And you are getting auto bed leveling, so that's extra good. But the only downside is you're going back to a Bowden style extruder, which really is going to be fine. As like you should be able to print most materials, and definitely TPU. That's as long as it's not like the most flexible TPU. Like I really like the SaneSmart TPU. I find that it does print well, and I've printed it through Bowden style extruders. But if you try to print something like Ninja Flex or something super flexible, it may not work as well. But what you are gaining is a larger build area, and potentially a more rigid frame design. And it's going to take up more space. I think it's probably going to be a little bit more involved to get set up. But basically you're trading build volume for the extruder type. And now you can upgrade, I think you can upgrade the extruder later if you wanted to, but again, you're increasing the price. So that's where it's kind of, it's like you might just want to just make that initial investment and get everything all at once. Now, if you really wanted all those features and the direct drive, here's the thing, that's going to jump way up in price, because it looks like the next model that has that is going to be the TronXY XY-3. And that's going to be also a larger build area. So that one's a 300 by 300 millimeter build plate, and it prints 400 millimeters vertically. So we're talking about equivalent to like a Creality CR10 size. It does have silent drivers. It does do direct drive and auto bed leveling, but that's $356. And at that point, then you're getting into a range where you might be, you're going to be comparing that to other printers like I can't think of the model, but something from Creality. I like the Focus Odin 5 as well. BQ makes different ones like in that price range. So then you're in like a whole different bracket once you get into that size and everything. But the point there is just that you can still get a decent size, larger print bed for the same price, but you give up that direct drive extrusion, as far as I can tell here. And then also, if you're curious, Creality Ender 3 V2, a very popular printer. That would be a next really good thing. Does that have auto bed leveling? I don't think it has auto bed leveling, but that one is coming in at $235, and it has a 220 by 220 millimeter print bed, and it prints 250 millimeters vertically. It does have silent drivers, but it still has the Bowden extruder. So that's why it turns out the Crux one is actually kind of special, because it's like a very small printer, and it has silent drivers and a direct drive extrusion for that price range, for under $200. So basically, if you are okay with the mini size and you want all those features, go with the Crux one. If you want a larger print area and auto bed leveling, but you're okay with giving up the direct drive, then I would definitely take a look at the XY-2 Pro, because that's like right in the same price range. Side note about the Ender 2 Pro, it sure seems like they're just really pushing that grab handle. They're like, man, look, the most important thing about this is you can customize this handle. Like, we want you to know that you can print any type of handle and really make this thing like yours with this handle, because it's all about the DIY handle that you can print. And it's like, okay, is that really the thing? And then also with where the handle is on all these printers, it's not gonna balance. Why doesn't the handle like kind of stick out over top of the print bed so that you can actually like grab the thing and have it balance? I don't know. Not really sure. So anyway, it seems kind of weird that they like really like went heavy on the custom DIY handle thing in their marketing. But hey, you can do it. Also, I will say the Crux one just has a very clean design. I feel like, yeah, the Crux one looks very clean. It doesn't have a bunch of motors sticking out all over the place compared to the Ender 2 Pro. And then the Prusa Mini, again, that's just like totally different price range. Like you're probably a different person that would be looking at the Prusa Mini, because you're probably already like a Prusa person, and that's not a bad thing. It's just that you probably already own Prusa printers and you just want a Prusa printer, but you want a small one, and that's probably why you're getting the Mini. But the Prusa Mini, I think it looks really weird. I think it looks very DIY. It does not look very like slick and streamlined. There's kind of stuff hanging out all over the place. It's got those guide rods that they're just kind of, yeah, it looks very DIY. I will say that. It probably prints great. I don't know. I mean, Prusa is supposed to make really good printers, so it's probably a great printer. And again, big thanks to TronXY for sending me this printer for review. I'll have links to all this stuff in the description down below. Thanks so much for watching, everybody. If you have any questions or comments, leave them down below. Until next time, go print something awesome, and I will see you on the next one.
We get bars in our goggles.